All right, some quick examples of using the power rule with a rational power. And if you've been working with us through the book, you've actually already used some of these because we know that the derivative of square root of x is the derivative of x to the 1/2. And by the power rule, that's 1/2 x to the negative 1/2, which can be rewritten as 1/2 root x. Notice that this is defined at x equals 0, and this is not defined at x equals 0. And if we take a quick look at the graph, we see why. The function is equal to 0, but that's an endpoint, so the derivative is not defined. Another example, the derivative with respect to x of the cube root of x squared. This is the derivative with respect to x of x to the 2/3, which is 2/3 x to the negative 1/3, which is 2/3 times the cube root of x. Again, notice that the derivative is undefined here, but at x equals 0, but the function is defined at x equals 0. Again, why? If we look at the graph of x, the cube root of x squared, we notice that there is a cusp right there at x equals 0. Let's see, another one. Let's do the derivative of cosine of x to the negative 1/5. Well, chain rule. So very quickly, let's do outer, inner. So the first thing we're going to do is do the outer, derivative of the outer. So we've got negative 1/5 cosine x to the negative 6/5 times the derivative of the inner, and the derivative of cosine is negative sine. So we can rewrite this more simply as 1/5 sine of x cosine x to the negative 6/5. Okay, so a couple problems using the chain rule. This is going back. These are problems that are frequently done wrong. And the big deal with the chain rule is the whole idea of inner versus outer. It's really, really important that you know what inner and outer are. So when I've got a derivative of a function, dy dx equals 1 plus sine of y, notice that the derivative is a function of y, which means that this was an implicit differentiation. The second derivative of y, well, the derivative of 1 is 0. The derivative of sine is cosine times the derivative of y with respect to x. So when you write this answer, what you need to do, we never write solutions in terms of derivatives unless we can't help it. But in this case, we can help it because that derivative is 1 plus sine of y. Another quick example, y equals f of t squared, but f prime of x equals square root of 2 minus cosine of x, and we want to find the derivative of y with respect to t. So going back here, the derivative of y with respect to t is f prime of t squared times the derivative of t squared. Chain rule, inner. Oops, I'm using the wrong colors there. Inner and outer. Just trying to be consistent is all. And so then we need to rewrite this as well. F prime of t squared is the square root of 2 minus cosine of t squared. So now notice that we're not writing it in terms of the derivative, we're writing it in terms of the function, just like we did up here. All right, guys, a super short video. I was going to just lump in the recap with this because the recap's also going to be a super short video, but I think maybe I won't. So I'll be right back with the recap. Thanks for watching.